Hi there, Mr. Sutton bringing you this lesson on midpoint and distance. So for this one, we're going to find distances and midpoints of line segments in the two-dimensional plane. And for the real-life payoff, we're going to use midpoint to see where two boats should meet in an emergency. So to start things off, let's say we have 2 points on a graph, 2, 5 and 5, 1, and let's say we want to find the midpoint of the graph, the point that is exactly halfway between these 2 points. So we're looking for something that is halfway horizontally and also halfway vertically. Mathematically, to do this, we just need to average the 2 x values and then the 2 y values together. So we got 2 plus 5 for the x values, that's 7. Divide that by 2 and you've got 3.5. Then for the y values, we have 5 and 1. Add those and divide by 2. 6 over 2 gives us 3. And you can see this point, 3.5, 3, is indeed halfway between. So as a general formula then, if you have 2 points on a graph, you're just going to add the x's together, divide by 2, add the y's together, divide by 2. And these will give you the x and y value of your midpoint. So here's a problem where we can use our midpoint. We've got endpoints of some line segment at 7, -2, and -5, -6. Pause the video and see if you can use that formula to find the midpoint. All right, let's see how you did. So here's our midpoint formula, x1 plus x2 over 2, y1 plus y2 over 2. And notice this is a comma, so these are 2 completely separate parts of this point here. So then we'll have 7 plus -5 over 2, and then for the y values, -2 plus -6 over 2. So this is going to be 2 over 2, and over here we've got -8 over 2, which we can reduce to 1, -4. For our next example, let's use this in a real-life context. Let's say we have a sailor badly injured on a boat that is 6 miles east and 10 miles north of a home base. So here's a graph. Let's say home base is the origin. And 6, 10, right about there, there's our boat with the injured sailor. Now, another boat with medical equipment is, let's say, 11 miles east, 3 miles north. So let's see, 11 and 3, right about there. What point should they both head towards so that they can meet in the middle, right? I mean, that would minimize the amount of time it took, at least if we assume they're both going the same speed. Pause the video and figure it out. All right, so this is our midpoint formula in action. We've got 6 plus 11 over 2, and then 10 plus 3 over 2. So that's 17 over 2 and 13 over 2, which comes out to 8.5 and 6.5. And positive x values are east, positive y values are north, so there are our real-life directions. For this next problem, we're going to make things a little trickier. Let's say that we are given the midpoint of AB. It's this point here, 5, 8, and they give us one endpoint at 2, -3. They want the other endpoint. So how can we kind of work backwards using the midpoint formula? Well, I'm going to set up just the x part of my midpoint formula to start off with here. We know that the x value of your midpoint is x1 plus x2 over 2. So let's just plug in the stuff we know here. We know the x value of the midpoint. That's this 5 right here. And we know one of these 2 x values. It doesn't really matter which one. We'll make it x1. We'll call that 2. So at this point, we just have to solve for that other x value. Pause the video and do so. All right, so for this one, we have to multiply both sides by 2. That's 10 equals 2 plus x2. Subtracting 2, we get the other endpoint's x value at 8. Let's go ahead now, pause the video, and do the same thing for the y values. All right, so here's our starting point. We know the y value of the midpoint is the average of the 2 y values. And we know the y value is going to be 8 for the midpoint. And then for y1, we'll plug in this -3. Multiplying by 2, we've got 16. And then subtract -3, so add 3. That's going to be 19. So we come up with the other endpoint then of 8, 19. And if you wanted, you could average this together with the first endpoint they give you just to make sure it actually gives you this midpoint. So 2 plus 8 divided by 2 is 5. -3 plus 19 divided by 2 is 8. So we're good. Shifting gears now to another topic, let's say instead of finding the midpoint, we want to find the distance between 2 points A and B. How can we do that? Well, the good news is we actually already have all the math we need for this. Finding that distance is actually the same as finding the hypotenuse of a right triangle. If we just draw a little triangle out of this, that distance is the hypotenuse. Now, the difference between finding this kind of hypotenuse and, the hypotenuse of a standard triangle, most of the time they actually give you numbers for the two sides that you have to square and add together in square root. Here, you're not going to have these numbers for these sides. You just have these coordinates for these 2 points. So how can we turn these coordinates into side values? Well, this bottom side here is just going to be what you get when you subtract these two x values. So x2 minus x1. And if you want this other distance here, this vertical distance, this is just what you get when you subtract the two y values. We'll call it y2 minus y1. Well, Pythagorean theorem, a squared plus b squared equals c squared. So for the last side here, we need the square root of a squared plus b squared. A is just this x2 minus x1 business. And b is just this y2 minus y1 business. These are just the two sides of this triangle. So here is the distance formula, but we see it's really just Pythagorean theorem with x2 minus x1 instead of a, and y2 minus y1 instead of b. Now, the nice thing about this formula is that it actually doesn't matter what order you subtract the x values in and the y values in, because you're squaring it. So even if you subtract it in quote-unquote the wrong order, you're still going to get a positive number either way. So let's go ahead and use this now. Let's say we have some line segment PQ with these two endpoints here, and we want to find the length of that segment in simplest radical form. So we're talking about the distance formula again. Hardest part of this, I think, is just memorizing this thing. It's easier, though, if you remember that it comes from the Pythagorean theorem. And then let's pause the video and see what you can do with these. All right, so plugging in our numbers, we've got -4 minus 2 and 8 minus 5 inside those squared parentheses. So that's going to be -6 squared and 3 squared, which comes out to 36 plus 9. And we know 36 plus 9 is 45. Now, they said simplest radical form, so they don't want us to just square root this and get a decimal. Let's use radical form. So we can split this up into square root of 9 and square root of 5. Square root of 9, that gives us a 3. So we have then 3 radical 5 for the distance. Here's another example, just to make sure you've got the idea. Pause the video and see how this one goes for you. All right, so we have different points now. We're still looking for length, so we'll still start with our distance formula. And I'll do 2 minus -5, so 2 plus 5, and 6 minus 4 for the y values. So we got 7 squared and 2 squared. That's 49 plus 4, which comes out to 53. And the square root of 53, there's no perfect squares in that, so that is fully simplified. So that's it for our lesson on midpoint and distance. You will be seeing these two topics over and over again in places you wouldn't imagine in higher level math. So till next time, this is Mr. Sutton signing off.